In chemistry, yield refers to the amount of product obtained from a reaction. It's a crucial concept because it helps us to determine the efficiency of a reaction. Think about it. If you're trying to manufacture a certain substance, you want to know how much of it you'll actually get out of the reaction, right? In this video, I'm going to go over the definitions for yield, theoretical yield, and actual yield, and then we're going to solve a problem that my grade 11 chemistry students would solve. Let's get started. So as I've already said, yield is how much product is obtained from a chemical reaction. Now you can determine that yield theoretically with stoichiometry to predict how much you should get in ideal situations. Actual yield would be what you would actually get if you performed that experiment. So why is the actual and theoretical yields different? What separates our experiment from an ideal situation? Well, there's typically three major reasons for why this happens. One is in the experimental procedure itself, either with transferring solutions, the way you're filtering precipitates, maybe you had some splattering during the heating process. That can result in less yield. Our second one is impurities in the reactants actually used. It's hard to think of, but when you're a grade 11 student and your teacher says, here's some magnesium, you just take that as 100% true. That is 100% magnesium. But in high school, we can't afford that. So there are impurities in the chemicals that we are using, and that is also going to affect the yield. And lastly, there could be some side reactions occurring. So you may be performing one reaction, and yeah, the majority of what you're doing can be that reaction, but you could be unaware that the reactants are colliding with other chemicals aside from the ones that you were trying to get them to react with. And so you can get some side reactions occurring, which would also affect your yield. So how we calculate percent yield then is you take your actual yield, what you managed to get from the experiment, divided by the theoretical yield that you would have calculated from, say, stoichiometry, and times it by 100%. So let's see how this works if I were to ask you a percent yield question on one of my grade 11 chemistry tests. So here's the question we have. A student conducts an experiment to produce magnesium oxide by burning magnesium metal in air. She starts with 5 grams of magnesium metal. After the reaction is complete and the product is purified and dried, she obtains 7.2 grams of magnesium oxide. So part A, calculate the theoretical yield of magnesium oxide. I have a lot of students that typically have trouble with this question on a test because they don't recognize it as being a stoichiometry question, right? Typically, all these students are very good at stoichiometry and can do it, but they don't recognize it. They immediately go, how am I supposed to calculate theoretical yield? Simple. Stoichiometry. So let's write out the equation. So we have magnesium plus oxygen, which is going to give us magnesium oxide. Then balance your equation. Okay, so what do we have? We start with 5 grams of magnesium. We're just burning it in air, so we're going to assume we have excess oxygen. And we want to figure out the mass of magnesium oxide that is produced. Okay, so step 1, like any stoichiometry question, find the number of moles of magnesium. So moles equals mass over molar mass. So we have 5 grams divided by the molar mass of magnesium, which is 24.3 grams per mole. So that gives us a mole of 0.206. So 206 moles. Next would be a mole-to-mole ratio. So we want to know how many moles of magnesium oxide we actually get. So step 2 is a mole to mole ratio. This one's an easy one because it's 2 to 2 or just 1 to 1. So our moles would be the exact same. Right? So the moles of MgO are also 0.206 moles. And finally, step 3, calculate moles to mass of magnesium oxide. So mass, using that same equation we did in part 1, but rearranging for mass, mass equals moles times molar mass. So we have 0.206 moles. And the molar mass of magnesium oxide is, well, magnesium, so we've got 24.3 grams per mole, plus our 1 oxygen, which is 16 grams per mole. And we get a mass of 8.30 grams. And that is our theoretical yield. So question 2, what is our actual yield? That's right in the question. She obtained 7.2 grams of magnesium oxide. So that's our actual yield. So then finally for part C, to determine our percent yield, we're going to take our actual yield, which is 7.20 grams, divide it by our theoretical yield, which is 8.30 grams, and times that by 100%. And so that gives us a percentage yield of 86.7 or 87%. I hope that video helped. If you have any further questions, let me know in the comments. And also, if you're taking grade 11 physics for a limited time, I have my entire course pack for grade 11 physics with all the lessons and problems that you can download for free right in the description. Thanks for watching.